Welcome back, dear students. We are learning some techniques to solve some of the problems which are linked with fluid dynamics, and we have now we are here to determine the radius of a water drop falling through air with terminal velocity 0.12 meter per second. Viscosity of the air is this one. Density of the air is given. Density of water is given. What will you do? You have to find out the terminal velocity value given, viscosity given, density value given, and you are asked to calculate radius of the drop. So you will use the formula of terminal velocity, and it is 9 eta Vt divided by 2 rho g. So this is the formula to calculate the radius because you are asked to calculate the radius. So after putting values, all values, you are getting radius of the drop, which is moving with such a such terminal velocity through the fluid of viscosity. All other values are given, and you are asked to calculate the radius of that drop. You will use this equation, and after using this equation you will put the value, and then you will be able to calculate the radius and value of radius with this one. If you look at this problem is determine the radius of the water drop. When to calculate the radius drop through the air with the terminal velocity is given, the drop is given, viscosity of the air is given, density of the air is given, and density of water is also given. Then what will you do? You have to calculate the radius of that valve. The radius of the valve is calculated by using Stokes theorem, and by using the definition of terminal velocity, putting the values, you are able to calculate uh, radius of that valve which is falling under these conditions. That is viscosity of the air, density of the air, density of the water. If such types of problems are given and you are asked to calculate the radius, then you will move back to the Stokes law and you will use the basic definition of terminal velocity formula, terminal velocity, viscosity, density of that material through which the object is moving. And when you will put the values in the formula, you will be able to calculate the radius of that ball which is moving in downward direction. So here up to this point problem, we have discussed different types of the situations where we were asked to find out. Sometimes we calculated pressure, sometimes we calculated the speed by using equations of continuity. Then we used the knowledge equation, and basically these are the two types of the equations which are used to prove. One is used to prove law of conservation of mass, other one is to prove law of conservation of energy. In case of the knowledge equation, in case of law of conservation of mass, we use equations of continuity, and these equations are very much helpful as the backbone for the learning of fluid dynamics. Thank you very much for your attention.